Yes, I'm sure I want to start. So I have no idea if this works. Looks like something happened, but still black. Okay, looks like we are live. OBS looks good. Maybe I set up the bitrate too high, as always. Microphone should be much better this time. I really have a microphone. And cameras also. Okay. So, it's quite late in Germany. It's 21:30. I think I can read on the clock behind me. And yeah, after the last video, a company called Kaiweets from China contacted me and asked me, "Oh, you want to test one of our multimeters, or DMMs?" And I say, I have a bunch of it, but I need a power supply. I need a second power supply. And they say, okay, we sent you one. And it arrived very fast because this company also selling over Amazon. They have their shops in Amazon, and so it arrives a few days later. And this is the first video of a series. I will check more detailed later, not tonight. Maybe half hour or 1 hour stream just for fun, and see what we can test in this time. For the power supply, let me switch to the other OBS scene with the computer on it. Because I'm doing live video. So I hear about the rumors that people get, or they have the fake reviews. Of course, you get paid for reviews, but I don't want to make a fake review. So this is live. What we see here is my live reaction to it. I'm accepting not so much because it's a 80 euro device. It's 300 watt, 30 volt, 10 amp, and a switching power supply. But we will test something with the oscilloscope. That's also why I have set up the other computer, so you can see the oscilloscope, and maybe we will do some efficiency. But I have no load for 300 watts. So we will see what happened. This is the German Amazon website. It's the Kaiweets 30 volt DC 0 to 10 amp. And what I like is the power supplies I have now, or my main power supply. It has those memory functions. It has 4 setups you can save. But when you want to change the voltage fast, you have to go to the menu, set up the voltage, set up the current limit. And it's a little bit not complicated, but you have to do more things. And I was looking for a power supply that has only the knobs to adjust voltage and current, and this is one with this. So actually I was looking for something like this in the sub 100 euro class, because for my lab I don't have the budget for 300-400 euro ones from Edgeland, or what the names are now, Keysight, or even Sigland or something else. So I'm looking for the cheap stuff for hobby. And if it is safe, if it is work, we will see. We will take it apart later. And this is the one. I will give you the links to the products later. I think there you can also get it. What they sent me was a link to the US website, but this is the same on the German website. And here's a pack. Here would be the package, but I have to switch the camera back to this. If the voice change, depends on how I sit here. It's because the microphone is up there. And so when I turn this way, it should be louder. So don't worry. I will set up the microphone later. And this is also a cheap one. This is the box. Quite big. Yeah. I'm not sure. Should I set up the camera different? We will see. We will unpack it. This could be loud. Sorry. It comes also in the Amazon box, or the box inside the Amazon box. Very stable, 2-layer cardboard. Manual. Maybe you don't need a place for it. There. So I just unpack things and then I show you what's inside. Yeah, very cheap. This is crappy. Enough place behind me. Okay, it comes nice foam. Very good package. No complaints about this. It's lightweight, but this is something I just know about. It is switching power supply inside, so it is not so heavy. My other one is an Kaiweets KA 3050 something 30 volt 5 amp, so 150 watt, but it's very heavy because it is a linear power supply with an iron inside and copper, and very heavy, very heavy. Both techniques have advantages and disadvantages, and if you're interested in this, maybe I make a video and explain how they work. Yes, I know. But for example, in a linear power supply, the energy that is not needed and the output, like you have a 30 volt transformer inside and you only need 5 volt at 2 amp, 25 volt at 2 amp just goes at heat outside of the machine or the power supply. So about 50 watt just dissipated by heat, and that is something should not happen with switching power supply. So okay, let me see if I can. It works. I can just focus on it. Something I like is it has the 5 volt output USB. Sometimes my projects I just can need a USB power and just plug it in. You have the knobs, coarse and fine adjustment for constant voltage, constant current, also probe coarse. Yeah, write it here, and fine adjustment. So yeah, let's see how it works. It has the just standard banana plugs. You can open them. They have no little holes inside where you can put your cable through, but it would be nice. First disadvantage, it's okay, don't need to be picky. Even if you buy it as a cheap one. Case is manual. Looks not bad, has a big vent in the back. It's set up to 220, that's right. And a standard plug. So what comes with it? A manual. Press on the camera. Works. So the manual, PC Power Supply 3010 DF user manual. Scan for video instruction. No, we don't do this. User manual in English, Bedienungsanleitung Deutsch. Oh, that's a German part. Pictures. Introduction. Operation. Technical parameters. 3 years warranty. Okay. Einführung. Sehr geehrter Kunde, vielen Dank für Ihren Einkauf. Dieses Produkt entspricht den gesetzlichen nationalen und europäischen Anforderungen, um diesen Status beizubehalten und einen sicheren Betrieb zu gewährleisten. Müssen Sie als Benutzer diese Bindungsanleitung beachten? Of course. They tell you they have warranty and something and it's safe, but you have to follow the instruction. Yeah, of course we follow the instruction. Always. This is important. I'd say it's for education. Not for industrial use. They are honest. I'm sure it's not for industrial use, but for me it's okay. It's hobby. Einstellungen. Wählen Sie den Kupferungsregler, verbinden Sie die Output-Anmerkungen. Der Arbeitsmodus wird durch Belastung und Traktionsstrom bestimmt. Im Konstantstrommodus wird die Spannung durch Last bestimmt. Je kleiner die Last, desto kleiner die Spannung. Hä? Okay. Yes, it should be okay. I understand what they mean that. A little bit complicated. So far I don't see any of this crazy Chinese, English, German, Google translations. Oh, don't open it. Versuchen Sie nicht, das Gerät zu reparieren. oder zu beachten, es sei denn, Sie sind dafür qualifiziert und verfügen über die entsprechende Kalibrierungs-, Leistungstest- und Serviceinformationen. Don't try to repair the device or tinker with it. You're not qualified, otherwise, or you are qualified and have the manuals and the stuff. We don't have, but it doesn't matter. Cleaning. Use a towel with a little bit Reinigungsmittel, cleaning fluid, and water. Don't squeeze the cleaner directly on the device. Bad idea. Okay, here we have something of the translation. Da er in den Schrank gelangen und Schäden, Schrank in Germany is a carpet, something, Schrank, big one behind me. This is Schrank, because it's case, translation. It happened. It's okay. Don't use chemicals like Benzin, Benzol, Tolul, Xylol, Aceton oder ähnliche Lösungsmittel. No, bad idea. Don't use Scheuermittel. No, we use Scheuermittel for the toilet, not for those things. 3 years warranty. Oh, don't read this. Okay, manual's not bad. So far as I can see. Let's see worst. So, what else we get? We get a power lead. It's the German plug or the European, no, German. I should look where I can plug this in. I'm really running out of plugs. Underneath this one. Okay. Then someone has to explain me why they deliver multimeter test lead. Okay. I think something went horribly wrong. You cannot stick this in, but hey, nice leads for multimeters, and I have already idea what we can check this. How we can check this and this at the same time and see what happened. Bad ideas. Another video I explain how to check the quality of a multimeter test lead without disassemble, without cutting it open to see how thick the wire is inside. Just making short circuit and measure the voltage that drops over the cable. I think we can do this. I bring a lot of multimeters beside me, and well, this cable is also, the cables I built are much better. So let's see how it looks. Oh, it's not as thin as I thought, but it's not as beefy as I usually use for power supplies. It's okay for my parts behind me. There are a lot of cables inside already. So, should we power it on? And then we take it apart. We are in science. Let me check. I like to check the computer, see what happened. Okay, they tell me I have a too high bit rate. Doesn't matter. We like high bit rate. More power. So, hope nothing worse happened. I have to work tomorrow. Connected. Now I cannot show you. Let me think what I can do. OBS. Maybe I should give the overhead camera another direction. Maybe in front of me. Let me see if I have something to put the camera. Ooh. Hand cam. No, that is not the best idea, to be honest. Okay, I should sort this before I go live, but doesn't matter. No, no, no. That looks weird. That looks weird a little bit. Oh. Sorry. That is a close-up. Okay. Just power on. I think most of you are interested how it looks inside. Okay. The fan comes on for a short time. Okay, it's in current. It says constant current. Of course, I turn down the current. Okay, now it goes. Oh, I just realized it also has something. Just show the wattage already. So even I cannot show. Maybe like this. Yeah, everything is in view. Maybe this is not the best idea. It's live. It's live, so it works. First thing, just check the voltage. Bring in one multimeter. 32 voltage. Get one test lead. A good one. Just had some burn marks. It's maybe a little bit bright. Better. But I like it's quiet. My other one, it's quite loud. But I think when I get the 300 watt out of it, that it is capable to do, it will get much louder. But yeah, how to say? We will see. So it doesn't go totally to 0. It goes to 0.0133. It should be okay. I don't know why I get 3 amps here. Okay. I don't know where it goes. Maybe just a little bit off, but for my purpose, it's okay. I really don't know where it goes. So, oh yeah, I'm some current now. I need to give it some current. This set the course. Oh no, it doesn't show. Like, I think when I totally turn it down, it has problems to show. So, and now fine adjustment. I want to go to 16. So, at the moment, it looks quite the same on the multimeter, 15.82, 15.82. Not too bad. Fine adjustment. I'm not sure if I should use the fine adjustment later. 16.1. Okay, compared with my Unity 61E, the European version with good input protection, looks not bad. So 4 amps. Set up the current, yes. I remember I have an older one, a standard and totally old multimeter behind me, someone. To set up the amp, the current, because this has no switch to set up and check what it has, like my other one, I need to make a short circuit. No, we can already use the multimeter. Going to amp. It should be okay. Yeah. So now it shows us we have 4.24 amps. Also, this is the settings for it. This is the constant current. And at 0.48, also at 480 millivolt, that is the drop through the leads, and the drop through the shunt in the multimeter. We get this, we're dissipating about 2 watt at energy into the meter and the cables. They didn't get warm. And you see my cables are still not the best, so I still should get, let me see, get other cables. This is more beefy. But also here, the contacts are still not so good. You don't see this. It's live. Oh, it's even worse. Okay, the cable is longer. 500 millivolt, about 3 watt. So now I can set up the limit. Just go to 10 amp. That is also what the meter can do. And you see at 10 amp what happened. We are already dissipating about 30 watt over the wires and the shunt in the meter. And if we get on the reading on the meter, the reading on the power supply tells us we have 9.99 amp and 9.96, so it's a little bit off, but not too bad for the reading here. Let's get another meter. We have enough meters for testing. Oh, maybe I'll make another short circuit. Get this one. Amp. 1.1, and this shows 9.97. This is a meter with a little bit less digits than the Unity, so we have the different readout. Don't like it to have 10 amps all the time, so we just go down and I set it up to 5 amps. First the coarse one and then the fine adjustment. I have to get used to it, but this works fine, and the display is very, very readable, I have to tell you. So this thing works well. The constant current and the constant voltage works well, and there's no problem with the short circuit protection. Short circuit protection? Yeah, I think so. Go back to this side. Now, what can I check now? Somewhere is my electronic load, and that would be now. Just put on the electronic load, see what happened. Now what it doesn't have is what my big one has, is a button. I can still have the power supply on, but I can switch out the outputs. So just remove this. Cables to the side. Where's my electronic load? And my electronic load is not charged. I should know this. But this is the smallest problem. My electronic load is only capable of 50 watt. So need to be a little bit careful with 10 amp. But it should be okay. There we go. We have an electronic load. Electronic load. You can see it a little bit. I've set up a little bit more things now. Put the electronic load here and switch on the oscilloscope. Now it gets loud. My oscilloscope is quite loud. And where this computer. Because I want to test the ripple, when I find this phone. Okay, what do we need? We need need more wires. So from the power supply, it goes into the electronic load. Do we work with a constant current or? I set the constant load to 1 amp, then it takes 1 amp, doesn't matter how much how high the voltage is. So from there we go to table get very full, so we get out the little ones. I like the little ones. Good old anhängs. One for voltage, one for amp. Then we go to here. From there, it's fine. We go here. This was for amp. We go here. Okay. Getting 15.6 watt now. No problems so far. And I want to check the real voltage. There I need to get another 2 wires. Here. And this I measure. Would measure here if it fits. So, tell you the tape. Okay. Ah. So 15.94 under load and 0.968 amps. So can run this for a while, but we can have also more. I say it can go to 50 watts, so I can just raise the voltage. So still 1 amp. The power, the current protection, constant voltage, constant current works well. And just turn this down. Maybe just go to, it's a little bit tricky. You see, I have also to try this out. I set the constant current to 1 amp and it can bring it now, and so the voltage drop down because the electronic load want 1 amp, and it just turned down the internal resistance, so the power supply, the voltage drops because I set the constant current too low, down to 1 amp, or lower than 1 amp, and so the voltage drops to 0. That's also normal. Things you have to, it's like everything goes together. Just set this higher. So I tell this guy can do 50 watts. That's totally limit. So, and so yeah, you see what happened. Now I raise the voltage, but my electronic load cannot do more than 50 watt. So, and now you hear the ventilator, the fan, and the electronic load is ramping up because it's getting a little bit warm in this small case. But this one still cannot hear. And for me, this area 50 watts is more than enough for most of the things I do. I never need about 300 watt in a bench power supply, but you can see this thing works very well. Last thing I want to test before I take it apart, because this is really just the first impressions of this device. I really want to see the efficiency. So now I'm taking about 50 watt out, but I'm interested in how much energy goes in. So for this, I prepared something. Can I find it? That could be the button. So kids, don't do this at home. I just make this little box. We have a normal plug. The box between. The cable goes to the power supply. Because I want to measure the amp current that goes into. And these two leads. And I use the protected one. So it's not really safe, okay? Trust me, what I'm doing now is not safe. So, just need to make the setup a little bit. Then maybe go to the oscilloscope. Well, this we do tomorrow. It's getting late. And we want to take it apart. I want to take it apart. I want to have a look inside. So, unplug this, unplug this, unplug this, unplug this, unplug this. Getting out the cables. Because I don't need to measure the output. And for this I will use the big ones. One for voltage, one for amp, and I hope I don't mess it up. I just use this one. No, I use my standard one here because I can switch off it remotely from here. So and the battery is full. You know, I can switch it off from here, so I can mess around, switch it on when I have no hands on the line, because in Germany we have 230 volt line voltage. It's a little bit higher than in US, and I don't want to touch it. I touch it when I start with electronic. It's normal. You will always touch it. That will happen. I try to stay safe most of the time. Bong. This I plug in here. Then the cable goes here. Then I need another 2 cables. To get cables that don't fall out. Really, don't do this. I have child protected there. But there is. Yeah, I have more here. Oh, this is always under power. Bad idea. The question is, what should happen? Can I get the voltage? Because to have the efficiency, I need both. I need the voltage and I need the amps. So I should be better prepared for the stream. But again, this is live. Just work on it. Okay, this can I put it down there. Far away from my fingers, from my hand, from everything. this in. Everything should be okay. Nothing should happen. I hope so. And no, the channel is not begun to become a second electro boom. No, I really don't want to do this. I need this. Really don't do this. Don't do what I show. Really, really don't do this. It's the worst idea. Really, really worst idea. I should prepare a little bit better for this. But hey, it's getting late. 22 already. This is far away. And don't put this into settings. So this meter is at voltage settings. All right. This is parallel to the wall. This meter will measure the amp and getting like this. So cables are live. Have to angle them a little bit. Make it a little bit longer. No. By the way, this is how I like electronic. Just tinkering around with it. Okay, cannot place them at the same place. Otherwise I get reflections from my overhead light. So, set up the electronic load. That is the most not dangerous part. I hope so. Ooh. So remember, should be okay. You can read. I think that is not bad from the position. We check if everything is okay here. Yes, not bad. Really doing dangerous stuff for you. So I'm not sure. Maybe I should just the energy. Okay, we are still having the 50 watt. We don't have. Whoa! Today we have a lot of voltage. AC, of course. So on this side, on the power supply, on the output, at the moment, we can get more. Should go to the 50. We can do a little bit more. Just for fun, I try to adjust totally to the 50 watt. Okay, we have to switch between. Easy to calculate, give me the 50. This is totally down. It's a little bit, no, I'm not nervous. I'm not afraid of 240, 238.3 volt down here in my basement. No one can rescue me. Okay. Did I say that I wanted the power supply with the classic? No, I think the other one is not so bad with dial in and turn around with a rotary encoder and go to 5-volt steps or 5 millivolt steps. But this is faster. So now we have 50 watt at the output. And on the input, let's give me the paper. Maybe it's good for something. Yeah, this cable has 230. Hope the insulation is. Isolation. I hope the cables are good. So, what do we have? We have 238.4 volt at the input voltage, and we have 0.45 6 amp at the input. And the calculator. My face recognition. Rechner. No, it's too late to do it with the hand, okay? So 238.4 times 0.456. Whoa, efficiency is not so good. We have at the input of the power supply, we have 108.710 for watt. So half of the energy. Also, we only get 50 watt out. But I think, to be honest, I'm not sure if this works. Maybe this is a switching power supply. And the meter just level out. So the power factor is bad. 0.5 about. But I'm not sure how the efficiency is. This I have to read. Oh. Or I need the special meters that shows the real load and the capacity load. I forgot the name. The parasitic load. So, especially with the switching power supplies, I don't think it is 100 watt, because then the fan already need to run. Because the 50 watt that I don't get out of it has to be converted into heat inside. That is why my other power supply is so loud, because this surely do it, because it's more like an ohms load and a resistive load always, because of the transformer inside. But switching supply should not do this. So I'm not sure. Leave a comment if you know it or how I can measure it. Maybe I have to hook up the oscilloscope, but no, this is too dangerous. This I won't do. Really have to check this out. I'm not sure. I thought it would be easier, but it's not. And maybe someone is there. No, no one is there. No live views. Too bad. Makes me sad. Not really. I can go down here a little bit. So I go down to 1 amp on the output. A little bit. So maybe have about 25 watt. And do the calculation again. As this was with input 50 watt, output a little bit more. Can still read it, right? So now on the input side we have still 238.2 and 2.09. Loop. Something happened. 238.2 times 0.290. See? 238.2 times 0.290. 69 watt. Also not really. Not output side is 25. And this is 69.078, and output watt is 25 watt. Not sure. Maybe the efficiencies were really so bad. Of course, I'm using it in the, and you see the whole area, what it can do from 0 to 300 watt. I'm using it at this end, also at the beginning of what it is capable. And normally the efficiency, or the most efficient part, is at the end of the scale. So more here, more here, there, more at the 300 watt, not at the 50 watt. But I don't think it should be so bad. But I can be wrong. I'm not 100% sure if it is possible to use the this measurement for AC load. For DC, it's quite easy. For DC, you just measure what comes in and what goes out, and you have the efficiency between those. But for the AC, especially with a switching power supply, it's not so easy. So this was the part of just testing, a little bit doing around with it. Now I have to switch this off. Oh, switch the table off so I can remove the dangerous wires here. Switch these things off. I know you should not do, but it was something. Take it apart. Have the first look inside. Most funny part. Electronic load gets very warm. For this one, electronic load 50 watt is a lot. Make it a little bit. Remove the parts here. So this cable I will keep for the next test. Also here. Goes into the box of cables. And now the part we all like. Take it apart. I hope so. I like taking apart most of it. And by the way, I want the company to do some live tests. I'm not making a video what they want, or like, oh, check this video, can I bring it online, or you want to have something like what you want. No, and they was okay with it. So let's see, but I don't want to break it. I want to use it. The first impression is for about 80 bucks. What you have to pay for it? Pay for it. It's okay. Okay, this screw bring. Okay. Here's some screws around it. Okay. This is always the same garbage, I know. But this screws will not work after it. Or will not be easy to reuse it. Electronic load is still cooling down. So, and if you want to support me, just subscribe or go to my Patreon page. I have a Patreon page, but I pay more things. I'm paying more than I get from Patreon. To be honest, I get nothing from Patreon, but I pay a lot. No, not a lot. $5 a month for my most favorite channels. All screws are the same, by the way. 1, 2, 3, 4, 5, 8. 8 of them. It's a handle. Handle is very nice to remove it. Okay. Looks like a switching power supply inside. Before I touch it, could be a bad idea. It was just powered on. I should measure the capacitors inside. Whoa, can't believe that this can dissipate or make 300 watt. It looks very, not many inside. Okay, on the front. This is the, okay, it has, I guess, it's just a guess because of the parts what I see. This is maybe the main, I'm using this before I poke in with my fingers. I guess this is the main transformer. And these are, why it has so many? I have no idea. Maybe I should really read the get the service manual with the service with the schematics. But I see this is a secondary power supply only for the display and for the not the control. The control is separately and goes directly to the main board. And they have a little bit hot slot here in red. Well, see. Some chips. I cannot read them. That's too small. My eyes are not getting better. But I can already see they don't remove the markings on the chips, or the chips have still markings. So this looks like a secondary power supply, switching power supply just for the display in the front, because of course when it goes to current limiting, putting down the voltage, whatever, you need power for this, and this looks totally like a separate one. I see some separations in this area. I see something on the big caps that looks like pleading resistors. Input voltage come here. It has some input protection. Well, whoever put in this bridge rectifier, full bridge rectifier, it's stylish. Maybe I should really use it as hand cam. I'm only a little bit afraid to get out the board. I think that it has some. I'm gonna be careful. Just unplug all the stuff. This is for the fan. So, fan. It's a 12-volt one. So, then they're going. This is like the power supply for the front panel. Then it has this, two ones and this one. We don't describe anything. What is what? They don't show you. Get this out. With the residue, you can see what's going where. I hope so. This is the one. Oh, this can be messed up. Power, signal, connection. Yeah, I'm sure this should not touch. Hope so. This is a 3-pin connector. This is also a 3-pin connector. I know that's a bad idea what I'm doing here. Or is this a different one? Let me see. Different one? Did I really put so much? Okay. Yeah, you can mess it up if you want, but with the markings, should be easy to put it together. I hope so. Ground wire. Oh, that's the ground, and here's a little cap at the output. Yeah, those two going just underneath. That will be funny. No heat shrink on the main power supply or main power switch. So I'm not sure if this has bleeding resistors. We will see. We will measure the voltage on the caps. Maybe they are already down to 0. Maybe not. We will see. This is also the same. Here also, it's really not perfect. No star washer on the ground. The ground wire goes underneath this 330 ohm resistor. I have no idea what's the purpose of this. Maybe it depends on this. So let me see. That's another one. Okay. Now we come in the area with the high voltage. Remember, I'm here in Germany. We have 240. Today it was about 240. So not the best voltage to touch. And there's the other earth connection. Also the earth connection. I'm not sure about the allmost, the black screws, but I think, let me check this. I'm just think or guess, whatever. They're not so conductive, and without the star washer, it's not the best. One hand flip over. Oh, okay. No. So when I put it together, I will use another screws there, make it a little bit safer, because you don't have earth connection. The earth lead, okay, it has a little bit metal here, but I'm sure that is not the best earth connection with this kind, and so I will not use another kind of screw. Not sure if I get it out now. Whoa. Okay. No, don't desolder it. Yes. Could say this is how you do it, but I'm not so impressed with it, to be honest. Nothing that can be fixed, that cannot be fixed, but no. Maybe from security points, it's not so perfect. Just check the leather wall caps there. Yeah, so that would be interesting. Does it have still charge? Okay, the good thing is my meter is not showing anything. So AC are the middle pins. That's already good. I could not get shocked by just touching the caps. Oh, maybe the little ones in the front from the secondary power supply. Yes, this is also 400 volt cap. 1.3, that is okay. 1.3, okay. Survive. And these are also input caps or output caps. Oh, these two also 400 volt. If I'm not making the video, I just would get it out. I'm not so afraid. I want to show all of you that I get shocked by the cap. Okay, that is also good. So not too bad. To show more, I have to desolder it or totally take it apart. And when I would do this, I really would remove some of the wiring here. I'm not impressed with the wiring to the front connector. And okay, this is just for switching the between 110 and 230 or 240. And it's also very nice. This goes to the switch or comes from here. So input, okay, input voltage goes there. Then the second pin goes to the switch, from the switch back here. So these two posts here are for the input. And to be honest, on the they have something here, but really not make as in that you can have a connector. I'm not sure why they do it like this, because I also guess it's not easy to solder in this position, and you have to. There's no other way. Oh, let me see. No, there's no nice way to solder these cables. So it's hand worked. It's handmade. This only works in China because it's cheap. I'm isolated, okay? Maybe this are these the pleader resistors? 5 watts, 330 ohm. Sure. I have nothing to check. Oh, I really need the schematics maybe. But it has some input. It has some separation here and here. Not sure why it has so many transformers. Oh, this is the main one. Oh, there. It has some separation around the main transformer, but still this whole side here, this whole area is the 200 or the 240 volt area going up to the totally to the front. A big separation between the lines here, so no worry about this. To the secondary auxiliary power supply for the display, and then this may be all the regulation stuff. This has separate. Okay, the separation looks good, to be honest. So I don't see any problems here on the first look, and I won't reverse engineering it. Again, it is an 80 euro power supply. This soldering I don't like, or these wires I don't like. They look beefy, but to be honest, I like the silicon wires more. So not happy with this, and this is very not thin, but yeah, I know with this cable you can almost get 1 kilowatt with this size. In Germany we have the 1.5 millimeters cable in the wall. It's a little bit thicker than this, but you can get 3.6 kilowatt because we have 250 volt, 240 volt. So that's okay. But I don't like it. Maybe I will just modify it later a little bit. And also when the ventilator, the cooling is too loud, maybe I can also work on this a little bit. So pull it back, and as mentioned, I just look for a normal metal screw because I really don't like this black screw. It's more like insulating. I want to have good ground connection for the case, and this is not the best ground connection. And no. I think everyone has a box like this. No. Oh. No. Maybe I should put in some exit. I don't have. This is too big. Oh. Let me test this. Close. That looks good. I should take this next time when I know that we have the every year as a company with public contact, we getting controlled by we get checked. All our computer things get checked for insulation. Not our computer, all our electric stuff, and with an insulation tester. I don't have one. So last time my good old trusty Weller soldering iron, almost 40 years old now, 35 about, I have at work, and they tested. Nice. Free test for insulation, and it passed. It was good. So if I know when they come next time, I bring this to work and just place it in the office maybe. And then it will be tested. And or maybe they have to, yeah, then they cut the wire if something is wrong. But it's just an insulation test. Should be not a big problem. This good. Look at this one. So what do you think? How good is the chance that it still works? That I don't. Oh, that is why they go through it. No, you can also put this way. I'd like to go through and resistor with the cable. Looks weird. So metal screw, much better. Better feeling with this. Okay, the screw posts on this board or on this metal case are very good. Shit. I say it should be easy. I'm sure this goes there. I don't think that the fan has an own power supply. Beep, beep, beep. Then this goes to the fan. Let me check from the residue. Oh, it looks perfect. Close. So then we have two 4-pin connectors. How do I do this? This has the residue there. This has the residue there. Oh, JP4, CVCA. Oh, I should revisit the footage. That would be too easy. Just see what happened. That looks good from the residue. That also looks good. So this one, I think, remember, was this. Looks also good from the residue. And this also looks good. I think it still works. More screws. So everything is plugged in again somehow, and it's already more safe because it has metal screws. Screws without anodization or something. It's just the screws. Like this. Yeah, also should. to smooth this. Oops. Oh, I will admit the game. 2 screws are enough. Maybe not the perfect one, just this one. Without this, need to open them. Just want to see if it still works. And then it's finished. Really, well, fits. By the way, this is the way I'm thinking around. So, still alive. Looks like it still works. Nothing broken yet. Plug in the constant. Plug in the constant load. Set to 1 amp still. That works fine. It's not broken. I don't mess it up. It's still work. Getting down the amp. Bam. Yeah, I really need to go. I really need to go. I really need to get used to this. More power. By the way, the fan is from the electronic load. What else can we test? Can I test? Go to the 50 watts again. Okay, now the electronic load. It's too high voltage. Oh, shit. Electronic load is, how to say, it can only get 24. So it has a little bit problems over 24. Oh, I can get 60 watt. 62 watt out of it. I don't want to break my electronic load, so we go down to 20. Ja, das war der wieder in die Mitte, dann den hier. So, the result. Yes, I didn't pay for it. It's 80 bucks when you want to buy it. They send it from Germany. It's not like that I say, would say, wow, this is the perfect power supply you can get for the money, or you can buy. But I would be not disappointed if I buy it, because I was looking for an switching power supply that can handle more amp or can handle more watt if I need it. Most of the time I will use it at 5 volt, 12 volt maybe, 2 amps to 4 amps, except I'm charging a battery, or I want to clone away something, clone a capacitor, or bring something to clone. Then I want to have more power. The build quality is it's almost time for bed. It's 2244. The build quality outside is okay. The knobs feel good. The potentiometers feels good. No problems at this part. Why they give you a test lead, I have no idea. The isolation inside, I'm not sure if it is a good idea to use anodized the black screws, and without star washers, the little washers that have the spikes. It's really better to make contact to the metal, to the earth connection. And so this is not the perfect. Oh, I know why I tested second power supply, tested 5V 2 amps separately. Sorry, I just see it on the thing. Maybe this is the second one. Maybe this is why it has three. It has one power supply for the display, one for the DC 5V 2 amp, and another one for isolate is dying. Has a hard time. Really a hard time. Restart always happens. So voila. I'm not like, oh, this is the best one you can get for 80 bucks. But it's what I expected, to be honest. I don't expect it something like perfect. It is 80 bucks or less if it is in the offer. So in my opinion, that is totally okay. Of course, I would like to see inside a Keysight one, but my wife won't give me the budget for it. And of course, Keysight won't give me one with 1,000 to 700 subscribers. No, you don't get the stuff from the big companies, but it's okay. So I have the hobby stuff, and for everyone who do it as a hobby and knows a little bit about it, about electronic or about line voltage stuff, and knows how to use it and makes no stupid stuff like me with the special wires, it's totally okay. Is it better to get a linear power supply? Maybe, but they are more expensive because the metal and the copper inside, that is what they make them expensive. For my 150-watt linear power supply, I pay about over 100 euros. So that was quite expensive, and it's not bad, but it's loud. This one at this settings, even with 50-60 watt getting out, you cannot hear anything, and that is what I like. When I make videos, I don't want to have the noisy fans. I have more than one then. So that's fine. Last test. Then it's really too late. I want to test these leads. Oh, the leads are they multimeter leads they put in the package. So I need to set up something and don't mess up the cables I have here. Oh, there. Good plate. Electronic load, no need. Das machen wir mal aus. Let me see if we can burn this cable. So okay, I need to make one contact here. I want to drive this cable into a totally short circuit, and because also on this wires, on this connection, there is some voltage lost. Good idea to put a cable that may be burned to a WD-40 bottle. What should go wrong with this? So then I need to measure the this is how we power it. So we go to a short circuit, getting the 10 amp already. 10 amp going over the cable. And we can also use this measurement. It says 11 watt. That's a lot, but I'm not sure if going over my cables that goes here or something internal resistance from the shunt that is measuring. Only thing I can say at the moment, it says we have 10 amp. maybe I should just trust this 10 amp and I don't need to cut so many. What I want to know is how many of this 1 voltage show here really drops over the cable. Because of Kirchhoff's law, the amps, the 10.28 amps is everywhere in this circuit, in this short circuit. So I just need to get another. Okay, now when you put it in short circuit with 10 amp, the fan comes on. But how often will I do this? Not so often, hopefully. To measure the voltage over this, I just need a short cable. Because the internal resistance of this meter is so low that it should not, yeah, the resistance of this cable is not so important. I hope so. So what we do now, we just say we have 10.28 amp at 0.6 amp. I need to go to the resistance. Oh, how's this from here? Is about 0.06 ohm, 6 milliohm. So let me check an old video of mine where I was measuring the leads from Untitled and all the other multimeters I have. So because I don't know okay, what the fan go on and off with 10 amp? Yes, it's really running at the limit. Okay, there is this video where I make also this test, and these cables have about, yeah, it's like the unnamed quality. So 0.056 ohm was the also 50 milliohm, 5 milliohm. Oder 0.0. It's, you cannot see this. 1 ohm, 10, 1 milliohm. 10 milliohm. 60 milliohm is this cable. Oh, it's getting a little bit warm, not too bad. And the earning was 0.058, but the Unity cable, the same length, was only 30 milliohm. So if I find the Unity cable, to be honest, I forgot which one it was. I think maybe it is this one. We should see a difference. We just make the short circuit of the Unity. We should get lower results. Before it was about. Okay, now we have volt. Yeah, you can already see. Okay, I hope you can see. I know this video get messy. Too many informations. With the Unity cable from the Unity meter, my best meter, we still have the 10.27 amps, but the voltage drop over this cable is not anymore 600 millivolt. It's only 262, and then this is about, I need this. Yeah. Did I make something wrong there? I have no idea. Yeah, it's almost the same like last time. 2.6. 0.6. There, 1 0, not enough. So the internal resistance of the Unity cable is half of the cable that delivers, but it's the same quality like the underlying meters. It's still okay for most of the things you do, but soon you can see how you can use an power supply to test your cables from the meters. And now we're just doing this last test. I'm getting a standard German 1.5 millimeter. Maybe I can just find one. The right leg. Not really. Okay. Oh, missed. Then one of my self-made cables. It's not the same length, so could be a little bit different. I like to make short circuit. So, and this we have 400 milliwatt again. So it's between the Allen cable and no, it's better than this, but worse than the Unity cable. I forget the Unity cable is so good. Okay, that's all for today's video. Lot of blah blah blah, a lot of chaos. That is how I like it. I hope some of you enjoy it. Pepe, muss morgen früh raus. Oh, my coworkers are writing something. How you know that I'm streaming? Ha ha ha. How much you understand, Max and the other one look like? Roman. Okay, my coworker today, he get a lot of shocks from the Fritzy unwrap from the electrostatic charge. And he was looking at this really weird websites with a wireless discharger. No, doesn't work. You need a connection to the ground to discharge yourself. Maybe I should bring him one of the cables. He can put it on his pants and let it go to the ground to make some. Yes. At Simulactus, Max, I'm always patient at work. Not only here, okay? And it's still early. It's 22:58, not 2 o'clock or something. So, thanks for my coworkers for watching. Do a review. That is a review, okay? Yeah, now it goes funny. I guess do a review about those fake things. Yeah, they are fake. Without connection to the ground, how could the energy go? Or you just want to collect energy somewhere else? Maybe, but for you, there will be a little bit bonus. Now with 300 watt, I think we can burn some cables. Okay, for my co-workers, watching this, we will burn a cable. Maybe we'll burn a cable. No, we will burn a cable. It's still this wire I have. Top stuff, doesn't matter. What's nice? Burning a cable? Yes, this is nice. You just wait that I burn myself, right? Play safe. No, not really. This cable is thin. That could be funny. And my co-workers are not into electronics, okay? Turning on the amps. Need something to protect my this silicon mat. more safe. Much more safe. What should go wrong? The nice is I don't need to calculate because this power supply showing the watt, how many watt goes into this little cable. Okay, we had constant current just now. That is what we expect. Nothing. Now, voltage up to the end. 3 amps, 8 watt. The cable is already moving. No, don't touch it. Don't touch this cable. Yeah, the insulation is already a little bit. Yeah, the smell is good. But we only have 10 watt. There can be more. Whoa, 70. Yes, that is what we are looking for. No, not too bad. Okay, that is the reason I need one of those power supplies. One more. That was fun. Next step. This is on 0.14 millimeter. But I guess this should have no problems, to be honest. Maybe it's getting warm, but should not burn just away. Remove the garbage. Maybe there will be light again. So the power supply doesn't explode. That is a good sign. Good quality. Yeah. And here you can see this cable with this diameter is just dropping 1.6 volt, minus a little bit from the other cables. And so 16 watt. It will get warm. It's 16 watt, but not like the thin one. So it's a little bit boring. Get the thin one again. Oh, we just wait. What happened? What is the time? 23:04. Really should stop this for now. Oh, but that's okay. Yeah, the constant current looks not bad. What else can we test? Maybe we should clone. It's warm, but not too bad. It was only a few watt. So, what else can we test? Some destructive work with it. Some cheap wires I have here? No. Maybe we should end this video for today. See you next time. I will check the ripples with oscilloscope next time and show you maybe I'll do modifications to it. Not sure yet, but it's really time. I I have my day off tomorrow. Don't need to worry about tomorrow. Ha! Genau, Max Payne. Don't. You have to work with the other one tomorrow. I have my day off. Good night, everybody. You don't know where the people watching, so good night, everybody. Good night, co-workers. And see you on my co-workers. I see you on Wednesday. No, not Tuesday. Wednesday. See you on Wednesday. And I'm still alive. I'm not killing myself with this. And I'm not sure if my co-workers see the scary part. I'm not sure. Bye-bye. Stop the stream. Where's the stop button? Bouton stop. End the stream.